Hello everybody, this is Itsu again. Yesterday I was demonstrating the Whoopee pulser. It's a car ignition coil which produces AC, and when you hook it up to this Capcoil it will produce some AC like waves. But the difference between the car coil I used and the flyback that was used by the other user is that the flyback has a built-in diodes normally, so this is pulsed DC and not AC as coming from the car coil. So I hooked up my flyback circuit. It's attached to this function generator, so I can change the frequency, and it's pulsing now again. Same 2 millimeters into this Capcoil, I call it. And I have again the red probe hooked up, and you can see that even with a flyback DC pulse, the scope will detect a AC-like pulse coming from the Capcoil. And the peak to peak is 60 volts or something, and the frequency is 10 megahertz about, which is determined by the number of windings of the coil. So that's just what I wanted to let you know, that there is no difference between using an AC source pulse or a DC source pulse. Okay, that was it for now. Thank you. The funny thing though is that with this DC pulse I'm not so fast charging this capacitor as I did with the AC pulse yesterday, so not sure what's the problem here, but it's going very slowly. Instead of yesterday it was in 50 volt within a few seconds, so not sure what's wrong, if it's purely the DC pulse or that something else is wrong. Have to find out. Hello everybody, this is Itsu. In my last video I showed that when using this what I call my Whoopee pulser, that we could charge a capacitor wound with a coil around it very quickly till 50 volts or something. And that was I thought because we were pulsing this coil with this high voltage coming from this ignition car coil. But later on I found out that that's nothing to do with this pulse. It's just coming from the high voltage from my catcher I used. My catcher, when I use it without the Whoopee pulser hooked up, it generates a lot of high frequency, and it's able to load this capacitor. You can see that this capacitor is 40 microfarad. It has a coil around it, 25-30 turns. It's not connected to anything. I have a AV plug connected, and this is going to the earth ground, and across the poles of the capacitor I have my Fluke multimeter hooked up, and it's in the DC, so nothing special hooked up. But when I now connect my catcher coil and activate it, you will see that immediately the voltage is going to climb on this cap. It's not hooked up to anything. It just picks up the high voltage from the catcher coil HF, and it starts to climb. So I thought it was this coil thing, but then I took also another similar cap, 30 microfarad in this case, without any coils, also hooked up with AV plug with ultra fast diodes to somewhere there, also hooked up to a earth ground, and also hooked up to a multimeter. And you can also see that this one is climbing 55 volts. So this loading of the caps is just coming from the HF and picked up by the AV plugs on the caps. I don't think it's any different. Yeah, you can see that the voltage is higher on this one, but it's a higher capacitance. So I don't think it has anything to do with my pulsing this coil for charging it. Another thing, a question I got was to find out the resonance frequency of the capacitors, but I was not able to sweep with my function generator to look for any resonance points of this capacitor only. And the specs told me that it's very low inductance, so probably there is little or no inductance in this capacitor, so I cannot find any resonance point when hooking up to my function generator and looking at the scope. You can see the voltage is still climbing, stabilizing a little bit now, 144 volts. And when I disconnect now the catcher, it's no HF interference on the meters, it's real voltage. Perhaps this one had a little bit, but it's now climbing. So there was no pulsing which caused this Capcoil, that I called it, to increase very much in voltage. Okay, that was my little report. Thank you for watching.